to the electricity section. So student uses the circuit below to investigate the characteristics of a filament bulb, calculate the bulb's resistance. If you want to know the bulb's resistance, basically you want to use this equation here, V equals IR. And what is the V is 4 volts, R we don't know, and I we don't know, so we need to work that out. How can we work that out? Well, the current is obviously the same everywhere, so if we know what the voltage across this is, we can work it out. So across X, the voltage is obviously 8 divided by the resistance is 3.4. 4 is 2.4 amps. So now here the voltage is going to be 4 divided by 2.4, which is 1.7 ohms, 1.6 recurring. Okay, the student now changes the resistor X to one with a resistance of 6.9 ohms. They calculate the voltage across resistor X will now be 6 volts. Use ideas about current, temperature, and the structure of metals to explain whether or not the student is correct. So most people had a pretty decent attempt at this question. A few people got 4 out of 4 because they missed out one of these things, probably the structure of the metals. And a couple of people just got the wrong idea, or a couple of people weirdly said the right sort of things and then they made the wrong conclusion. So we've changed the resistor X to one of 6.9. So the resistance of X has increased. So the potential difference across it has increased. The potential difference from the battery is fixed. So the potential difference across the bulb must decrease. So the student is wrong. Now that isn't enough, but that's the basic idea. Okay, this has a higher resistance, it's going to get more volts. This is going to get less volts. So what else is going on? Okay, so the total resistance of the circuit has increased, so the current will decrease across or through rounds in the circuit. Sorry, don't know where that started. So the current will decrease in the circuit. This is because there will be more collisions between the electrons and the metal ions. And a few people went even further, which is probably actually needed, but it was really good to see. A higher resistance means a higher density of ions for the electrons to collide. So it's not immediately obvious why this is actually enough. And actually, typically just those first 2 sentences is enough to explain what's going on. But the question, had this bit in here, it really, and I chose it really to test your knowledge. I wanted to see who knew this and who didn't. So it's not, the most typical question you'll get. but it's completely fair and it really is testing your knowledge. And there's a very big clue, okay, that is asking about this. So if you didn't, put this kind of thing in, you're not going to get the full marks. Okay, we now jump to something completely different. We've got this setup here with two polarizing filters and this circuit. And it says, describe and explain how the PD across the LDR changes as the second filter is rotated from 360 degrees from its original orientation. You don't need to do any calculations, but you should refer to the orientation of the filters and how they work. So at 0 degrees, maximum light gets through. As the filter is rotated by 90 degrees, the light intensity falls to a minimum as the polarizers block out all of the light. And then, just go to one page. It tells us to explain how polarizers work. So I'd probably say something like polarizers only allow light to pass through if all the oscillations are in the same plane. So if they are 90 degrees apart, not apart, if they are rotated by 90 degrees, their two transmission planes are not aligned at all. No light can pass through. So I think it's a bit of overkill here. I've written a fair amount for this. That's a model answer. So we've pretty much got most of the answer, haven't we? At 0 degrees, maximum light gets through. As the filter is rotated by 90 degrees, the light intensity falls to minimum as the polarizers block out all of the light. So as the polarizer is rotated by 180 degrees, the transmission planes are aligned again, and maximum light intensity passes through. At 270 degrees, no light gets through. At 360, maximum light. Something like this, okay? Most people summarize this a bit shorter, but that's the basic idea, okay? Every 90 degrees, you're going to go from maximum, minimum, maximum, minimum. And then there was one more thing, wasn't there? We had to say what happens to the PD across the LDR, okay? So LDRs decrease resistance as light intensity increases. So at 0, 180, 360 degrees, its resistance is a minimum. At 90 to 70, R is a maximum. When R is a maximum, PD is a maximum. When R is a minimum, PD is a minimum. Okay, so by R, I mean the resistance of the LDR. Oops. So, you definitely don't need to have every single word that I've written here. This is a bit longer than you would need to, but those are the basic ideas, kind of really explains clearly for you. Okay, multiple choice questions. This diagram shows 4 resistors connected between which 2 points is resistance and maximum. So with whichever 2 points we take, we've always got 2 things in parallel. We know the things in parallel, the resistance is always going to be smaller than the 2 individual resistances. So we need to make the 2 halves of the parallel circuit have as large a resistance as possible, and a little bit of playing around shows that between Q and S, we're going to have 5 this way or 5 this way, so the resistance will be 2.5 overall, and then no other way gives us as large resistance on each individual branch. Any other way, you're always going to get this 1 and a 2, for example, to have 3, so it'd be even less. You could do some calculations, but it's fairly easy to figure out. It must be Q and S. And then finally here, energy dissipated in the load over energy dissipated in the complete circuit is obviously R over R plus R. That was fairly well answered. I think almost everyone